Today we are starting Chapter 6. It's called Transformations. You might have seen some of these in art class actually in the past. They look pretty cool once they're completed. The first lesson that we're talking about is translations. So translation is a part of a transformation. Okay, so we're going to see some things how they move on the coordinate plane. So working with coordinate planes today. Some vocab words, so let's get our vocab sheets out and pause me if you need to. A transformation, there's a couple vocab words within a vocab here too. Transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. So there's a definition within a definition here. The pre-image, that is the original geometric figure. The new figure after the translation, after the transformation, is called the image. A translation slides a figure from one position to another without turning it. Now we have some notation here that when we're talking about images, pre-images are labeled just regular A, B, C, or C, D, E, whatever the name of the shape is called. The new image has to be written with that A and then an apostrophe B. This is probably supposed to be C, but it says A with that apostrophe is read as A prime. So we're talking about A prime. This talks about how when a figure is translated, the x-coordinate changes the value of the horizontal axis. That makes sense because it goes on the horizontal axis. And the y value, when it's translated, moves it up and down on the y-axis. So this right here is called translation notation. And we usually put numbers inside of that. And you'll see that one of those on your homework. When translating a figure, every point of the pre-image is moved the same distance and in the same direction. The image and the pre-image are congruent. Congruent figures have the same shape and same size. So line segments in the pre-image have the same length as line segments in the image. Angles in the pre-image have the same measures as angles in the image. Pause me if you need to get those notes down. So here they're telling us to graph triangle JKL, which they did for us, and it has these vertices, these ordered pairs. Then graph the image after a translation of 2 units right and 5 units down, which they have done for us here. And we're just going to write the coordinates. So I'm going to draw this in here, even though it is right here. So if we just double check, it said 2 units right, so that moves it 2 units on the x-axis, and then 5 units down. 1, 2, 3, 4, 5. So there's our L prime, which is at -2, -1, 2, 3, 4. Oh, that was L. -2, -4. J moves, it says move it 2 units right, so 1, 2, and then 5 down. 1, 2, 3, 4, 5. So that's at -1, -1. And K, 2 to the right, 1, 2, and 5 down. 2, 3, 4, 5. Good. So they have it all right, and that moves it to the ordered pair 3, -2. So I wonder if something with these 2 units right and 5 units down and these ordered pairs could somehow help me get there. I guess we'll have to discover that and figure that out on the next couple slides. So here's one where they didn't graph it for us. It says graph triangle ABCs with vertices 4, -3. So 1, 2, 3, 4, -3. So label that A. B is 0, 2. And C is 5, 1. So I'm going to attach those to make them look like the triangle ABC. And I'm going to use a different color. Then graph its image after a translation of 4 units left and 3 units up. Write the coordinates of the image. So that's going to be A prime, B prime, and C prime. Then fill in the box. Okay, so it says, I'm going to go with A. 4 units left. 1, 2, 3, 4, and 3 up. 1, 2, 3. So there's my A prime. So that's at 0, 0. B prime. 4 units left. 1, 2, 3, 4, and 3 units up. 1, 2, 3. So that's 1, 2, 3, 4, -4, 1, 2, 3, 4, 5. C prime, 4 left, 1, 2, 3, 4, and up 3, 1, 2, 3. So that's at 1, 1, 2, 3, 4. We can draw that in there. So here is my pre-image in the green, and my purple is my image. So left or right changes the x coordinate. So if we look up here, and we had to go from 4 and go 4 units left. Left would be subtraction. 4 minus 4 is 0. Right would be addition. However, we didn't move any of these to the right. Up or down moves the y coordinate. So this one said 3 units up. So up would be addition, and down would be subtraction. So we move this from 1 to 1, 2, 3. And that's where, or 4, I mean, from 1 to add 3, 4. So that's where these came from. So the translation notation for this, translation notation would be that all of our x coordinates moved left 4, and all of our y coordinates moved up 3. So that's what the translation notation for this particular problem would be. Okay, let's do one here. So it says triangle XYZ has vertices here, here, and here. Find the vertices after 2 units left and 1 unit up. So we can graph this. -1, -2, so that's my x. 6, -3, there's my y, and z is 2, -5. So here is my pre-image in the green. My image with ordered pairs has to go 2 units left, so that's going to be x minus 2, and 1 unit up is going to be y plus 1. So x, we have to move it 2 to the left, 1, 2, and 1 up. So there's my x prime. Z prime, 2 left, 1 up. Y prime, 2 left, 1 up. So it doesn't slide much or translate much, but it does have some. So my new x coordinates are -3, -1, which makes sense. -1 minus 2 is -3. -2 plus 1 is -1. Y is 4, -2, which makes sense. 6 minus 2 is 4. -3 plus 1 is -2. And z is 0, -4. And we could have figured that out with just using these and our notation, our translation notation, to figure out all our new ordered pairs. Which leads us into slide 6, which is going to ask us to do exactly that. Quadrilateral, so a 4-sided shape, 4 letters, 4 vertices, has these vertices. Find the vertices of the new one, the image, after translation of 4 units right. Okay, so that's going to be x plus 4, and y minus 2. So all of our x coordinates, we can just add 4. So we have a prime, b prime, c prime, and d prime. So if we add 4 to 0, we would get 4. Subtract 2 from 0, -2. 2 plus 4 is 6. 0 minus 2 is -2. C, we have 3 plus 4, 7. And 4 minus 2 is 2. D, 0 plus 4 is 4. And 4 minus 2 is 2. So there would be our new coordinates. That translation notation really does come in handy. Last one. A computer image is being translated to create the illusion of movement. Use translation notation. Here's our translation notation to describe the translation from point A to point B. So we go from 3, 3 to 2, 1. So we go from an x, we go down 1. So that's going to be x minus 1. And our y goes down 2. So that's going to be y minus 2. And there would be our translation notation. Shoot for the moon. Even if you miss, you'll land among the stars. So we are going to go over in class a foldable that you can use. Remember, you can always use your foldable. So in your book, if you want to tear out page 498, and in the back of your book, in those foldable pages, you're going to see one that looks like this, and it has some pages to fill out. If you take the one out of the back out, it says use your foldable to help you review the chapter. You tape it on the edge here. You cut out the solid lines. Just read the directions. We're in translation. So a translation, if we modeled that, we would just have something. My model, yours can be different, but we have like a triangle here, and then we move it here. Everything stays the same. It's orientation. We just moved it over and down. So, and then for symbols, I'm going to say, and I'm going to call this on the model a slide. It just slides it. And my symbols, I know that we take our x and we either add or subtract some number, and they in our notes call it A. And then we also take our y coordinate and we either add or subtract some number, and in our notes they call it B. So I'm going to say add equals to the right, and then over here add equals up. Subtract means left, and subtract for my y is down. So those are all things that we can use on our foldable. Take some time to fill that out so that you can use it later. Have a great day.